So for this lab, we worked on looking at the different effects on vegetables when they are in acidic or basic solutions. And these are the results for all the vegetables. So we have the control column right here. I just boiled them in water for about 5 minutes. I have the acid column right here. And I put them in boiling water with vinegar. And then the basic column, where I put them in boiling water with baking soda. So here's a cauliflower, and you can see it's a nice kind of off-white color after just boiling it in water. And the carrots still look pretty good. I didn't skin them beforehand, so it's a pretty average color that you would get whenever you boil carrots. And the broccoli looks very light green compared to the way it was when I bought it from the store. And the cabbage, it looks nice and purple, dark purple, a lot darker than it was when it was straight out of the bag from the store. And here is the cabbage water. This is just regular water, nothing else added to the solution, just water. And then for the acid row, here is our cauliflower. It's a lot whiter if you see compared to the control group, and it actually kind of just looks like I never even boiled it in anything because it looks like straight out of the package, but a lot softer. And this is what vinegar does since it's in acid. And then the carrots, also I think that the carrots look a lot better since it's a lot more vibrant in my opinion. Even though all these vegetables have been sitting out for about 2.5 to 3 hours, I think this carrot is more vibrant in color compared to the rest. Can't say the same for the broccoli. The broccoli is a dull olive green. The pheophytin, I think I'm saying it correct. So that's our broccoli. And our cabbage, it looks kind of purple, but definitely a lot lighter in comparison. And here is the water. It's a lot redder compared to the other one, which was blue. See the other one. So the reason why the cabbage turns this light purple, sort of reddish pinkish hue is because the anthocyanin is reacting with a low pH in the acidic solution. And that's why it has lightened up compared to its control counterpart, as you can see. And that's why the water has changed, because now it's in a lower pH than it was in this control solution. And then moving on to the alkyne row, I thought that I did something wrong at first because of how the carrots came out. I mean, even after sitting out for 2 hours, I mean, they look really, really, really bad. But it's because this, being in a basic solution, the pH is extremely high, and that makes the cellulose basically dissolve. And so that's why they have lost their structure. They're so mushy and gross. They have lost their foundation, basically their firmness is gone. And the cabbage is the best example because this is the same cabbage but now it has not only gone from a purple to a red, now it has gone to a blue. And I mean, I think that's so cool. And you can even see the water from the solution it was in. It's greenish. It was kind of blue, but it's green. And you can compare it to the red and the actual blue, the true blue from the original solution, the control. So if you look at the other vegetables, the cauliflower, so we have the control cauliflower, and then we have the acidic one, which is a lot whiter, and then we have the alkaline one, which is mushy, no shape. It's definitely yellow now. And the carrots, I mean, they look really bad, but you can see the mushiness. It's still very, very watery. It's like losing all of its fluid compared to the control and to the acidic one. It's still orange. This one has a better orange, even comparing it to the control. But yeah, that's the carrot. And then we have the broccoli, of course. I can't even pick it up because it's falling apart. Here, let me get this one. So this broccoli compared to the original one, I mean the control one, and the acidic one. The acidic one looks like it's been out for so long or something, like it's sunburned. And then we have the cabbage, which I compared, but just bring this one over here. I know, completely different. But that is the lab for the vegetables. I think this was probably the coolest lab I've ever done in any of my science classes. So we have all my potatoes here. They're just boiled in water and a bit of salt. And here's the all-purpose one, the red potato, which is waxy. And then we have the non-waxy potato over here. And I have to say, this is probably the best. I thought it was good. My family thought it was better than all the other ones. But I have to say, this potato tasted a bit earthy. This one was pretty good. It was second runner-up, but this was the best. Now, with the red potato, it definitely did hold its shape. So yes, the waxy potato is the best when it comes to boiling. And then the non-waxy potato, it did not hold its shape. Just picking it up out of the pot, it started breaking, as you can see. But it is great for mashing and baking and frying. And this potato did a really good job keeping its shape, but it's still soft enough to where when I mashed it, I didn't really struggle getting that nice smooth consistency. Here are my potatoes in their mashed state. I only used milk and butter. Starting off with this potato, the waxy potato, this was the hardest to mash because I used more time to mash and it still didn't fully mash. It still has pieces of potato that are unmashed, and it does, I guess, follow through with its word. It stays in its fixed state. It doesn't really mash well, but when boiled, it's great. They have been sitting out for about an hour now, and as you can tell, it's really, really thick. Like it hasn't gone any better. And that was probably the third place mashed potatoes for my family and myself. I did not like this one. And then we have the non-waxy potato, and this was the easiest to mash. It looks grainy now because it's been sitting out, but it was the easiest to mash, and it's a lot smoother. The consistency is nice and fluffy almost. The taste, not so great, but I'm pretty sure if it was paired with gravy, it would be great. And then we have my favorite and my family's favorite as well. And this mashed potato was just a lot creamier, I guess, a more smoother than this one. Because of its thickness, it gave it that nice creamy taste. And then I have to say this was probably not the easiest, but it wasn't the hardest to mash. So I guess it also holds to its name. It is all-purpose. You can mash it, you can boil it, you can do anything with this potato. This one, it was better when it was just being mashed, and this one was better when it was just being boiled. So here are the potatoes. And all right.